In the summer of 1944, American tank crews pushed through the tangled hedgerows of Normandy with an uneasy awareness building behind every advance. The dependable M4 Sherman, which had carried them from training grounds to the beaches of France, suddenly felt outmatched by a machine they kept hearing about in clipped field notes and grim after-action reports. The German Panther, with its long high-velocity gun and sharply sloped armor, seemed to turn up at the worst possible moments, often discovered only when a Sherman lay burning by a roadside or half-hidden behind a shattered stone wall. Rumors gave the Panther an almost legendary quality, the kind no crew wanted to believe but none could ignore. Evidence piled up far behind the front. Intelligence summaries and technical boards reviewed plate fragments, wreck photographs, and penetrations that were not quite deep enough. The standard 75mm gun had already proven itself against older German armor, but against the Panther's heavy, angled front plate, its shells struggled to leave more than dents and scars at typical battlefield ranges. Even the newer 76mm guns, installed on some Shermans and tank destroyers, often failed to punch through head-on unless the target was uncomfortably close. Crews resorted to flanking shots, slipping through alleys or hedgerow gaps to strike from the side, but in the cramped terrain of Normandy that kind of maneuvering cost precious minutes and often exposed them to enemy fire. On the other side of the ocean, ordnance engineers had already begun searching for a technical escape from this growing disadvantage. Test ranges and metallurgical labs had shown that German armor was increasing in hardness and thickness faster than conventional shells could adapt. The solution they chased was deceptively straightforward. If a lighter projectile could be driven at far higher speed and if its core were made from a metal dense enough to resist deformation, it might punch through armor that steel shot simply could not handle. Tungsten carbide became the focus, forming a tough core wrapped inside a lightweight jacket. Fired at very high velocity, this kind of round behaved less like a classic shell and more like a precision tool, forcing a narrow channel through armor with brutal efficiency. In theory it worked beautifully. Tungsten carbide did not flatten or snap the way steel sometimes did when it hit hardened plate at extreme speed. It kept its shape, bit into the surface, and carried enormous energy deep into the target. Firing tables showed that such a projectile could pierce armor once thought entirely immune to American guns. On proving grounds, the idea looked like a breakthrough that could level the field against the Panther. But on supply ledgers and shipping manifests, the picture was far less encouraging. Tungsten was scarce. The metal was already claimed by machine shops, cutting tools, and precision instruments vital to the entire war industry. Every tungsten core forged for a tank round meant something else, somewhere, could not be made. Production planners traced or shipments from distant mines, counted, recalculated, and still came up with totals that did not meet demand. The new ammunition was promising, but it would be produced in painfully limited quantities, far short of what frontline units needed. By midsummer, as the Normandy fighting ground on, commanders approved a crucial series of tests using captured German tanks. One of the major boards set up a firing range on the quiet outskirts of Isigny. Panzer wrecks were dragged in, cleaned up just enough for controlled trials, and lined against earthen backstops. Over several days in August, American officers tested every standard shell against the Panther's frontal armor, confirming once more that conventional rounds could rarely penetrate at workable distances. Then the experimental tungsten core ammunition was fired. The effect was unmistakable. On carefully measured shots, the new projectiles punched through the heavy sloped plate, leaving neat entry holes where ordinary shells had only bounced or fractured. The board's report carried a restrained tone, but the meaning was unmistakable. With the new hypervelocity ammunition, the 76mm guns could finally threaten the Panther from the front under the right conditions. Without it, American crews would remain at a severe disadvantage whenever they met the German tank head-on. Even so, the tests also made clear that supply would be the decisive factor. The ammunition was too rare for every tank, too precious to waste, and too slow to manufacture in bulk. By late summer, crates of the new rounds began trickling toward France. Compared to the mountains of standard shells moving up from rear depots, these boxes looked small and almost fragile. In some rail yard or forward dump, they waited under tarps, tagged for specific battalions and held back for the heaviest German armor. Meanwhile, at the front, most crews still loaded the familiar steel shot, still braced for the shock of facing a panther across a field or down a narrow road, and still hoped that the promised new ammunition would reach them before the battlefield forced the next encounter. The breakthrough existed, but for now it remained out of reach, another quiet hope traveling slowly behind the armies advancing through France. As the front pushed eastward out of Normandy, American units advanced with a strange mixture of confidence and caution. The German lines were breaking in places, villages were being liberated one after another, yet the shadow of the Panthers still lay across every field where armor might appear. Crews knew that somewhere far behind them, in depots and warehouses, crates of the new tungsten core ammunition existed, but they also knew those crates were counted in numbers that felt almost symbolic. Most battalions received only a handful of rounds, carefully rationed and issued with instructions to use them only when absolutely necessary. Logistical officers treated each box like it contained something priceless. They recorded its movement down to the hour, checked every seal, and signed reports with a seriousness usually reserved for high-level intelligence documents. At forward dumps, supply sergeants locked the small stock behind reinforced doors and reminded every visitor that this ammunition was not ordinary ordnance. A single tungsten core round had taken more effort, more negotiation, and more strained industrial capacity than most crews would ever know. Meanwhile, factories back home struggled to turn raw tungsten into finished penetrators in anything resembling real quantity. The metal had to be shaped with specialized tools, sintered at exact temperatures, and manufactured with tolerances far tighter than normal shells. Workshops that normally built aircraft parts or machine tools were temporarily reassigned, their workers trained to handle the brittle but dense carbide cores. Even then, output crawled forward at a frustrating pace. Production managers worked long hours calculating how many new rounds could be completed each month, only to update the figures when yet another critical tool wore out or another shipment of tungsten or failed to arrive on schedule. The pressure stretched all the way to the battlefield. Tank destroyer battalions along the Lorraine front began receiving tiny deliveries, often just a few rounds per vehicle. Crews placed them carefully in their racks, separate from the usual ammunition, marked with small chalk symbols or strips of tape so they could be found instantly in an emergency. The rounds felt like a secret advantage, something almost experimental, more promise than certainty. No one wanted to fire one unless the target absolutely demanded it. On misty mornings, when German armor was rumored to be probing through the villages east of the Moselle, tank commanders would run a hand across their ammunition racks, feeling the smooth jackets of the tungsten rounds among the heavier steel shells. That brief touch was a reminder that technology was racing against time. Every patrol brought the possibility of meeting a Panther or a Jagdpanther full-on, where only these rare hypervelocity rounds might make the difference between a burning wreck and a battered but surviving crew slowly backing out of the fight. As the autumn rains settled over France, the problem grew sharper. Roads dissolved into mud, trucks bogged down, and supply convoys slowed to a crawl. Even ordinary ammunition struggled to keep up with the advancing divisions. Precious tungsten rounds moved even more slowly, handled with care, delayed by weather, rerouted by broken bridges, or held back for units judged most likely to encounter heavy German armor. Somewhere along the chain, crates disappeared into paperwork limbo for days or weeks, while at the front, tank crews fought with whatever they had. Yet the hope persisted. The crews talked about the new ammunition as if it were a kind of talisman. If only it arrived in time, if only enough of it reached the battalions that needed it, maybe the next firefight would be different. They imagined a moment where a Panther crested a ridge or rolled out from behind a barn, and the tank destroyer across the field would have just enough tungsten rounds to change the outcome. It was a thin hope, but in the grinding advance across France, even a thin hope was worth holding on to. By early September 1944, the war had moved far beyond the hedgerows. American columns were stretching east across France, chasing an enemy that sometimes seemed to be collapsing and yet somehow always managed to stiffen around every key town and road junction. On paper, the advance looked impressive, but along the lanes and fields of Lorraine, German armor was still very much alive. Where it appeared in strength, the familiar pattern repeated itself. Panthers and other heavy vehicles would anchor hurried defensive lines, relying on their powerful guns and thick armor to buy time for infantry to fall back and regroup. Into this uneasy landscape rolled units like the 704th Tank Destroyer Battalion. Its crews had already learned the hard lessons of Normandy, the need to move fast, to use cover well, and to remember that enthusiasm did not stop an armor-piercing shell. Now they were working alongside armored divisions near places like Lunéville, where rivers, woods, and small towns created natural choke points. It was in this setting that the rare new ammunition would finally move from test ranges and depot shelves into real combat. The first batches of tungsten core rounds reaching these battalions were laughably small compared to the crush of ordinary ammunition. A truck might arrive at a forward position with thousands of regular shells and only a few cases of the new high-velocity armor-piercing type. Officers gathered around the crates, reading the stenciled markings and comparing them to the latest technical circulars. Somewhere above them, a chain of ordnance and supply decisions had judged their sector important enough to receive a share of the scarce metal. Crews reacted with a mix of curiosity and quiet respect. Gunners studied the slender projectiles, noting their lighter feel and slightly different shape. They were briefed on what the engineers and test boards had concluded. At close to medium ranges, especially against heavy German armor, these rounds offered a chance their standard steel shells could not match. Against lighter vehicles, they would be a waste, throwing away precious tungsten on targets that conventional ammunition could handle just fine. So the battalion adopted its own habits. A few tungsten rounds in each vehicle, set apart in the racks, mentally reserved for one purpose only, to meet panthers and similar threats head-on when there was no better choice. The terrain around Lunéville forced decisions quickly. Narrow roads curled along wooded slopes and dipped through shallow valleys. Sight lines were broken by farm buildings and hedges. It was the kind of country where a tank or tank destroyer could be ambushed at 200 yards or less and where a panther, properly positioned, could see down an entire approach route. In mid-September, contacts with German forces intensified as both sides tested each other's strength in the region. When the heavy German armor finally appeared in earnest, it did so with the usual mixture of boldness and caution. Panthers tried to use their advantages, holding hull-down positions behind rises, covering open fields, and relying on the confidence that their frontal armor had earned in earlier battles. American tank destroyer crews, in contrast, tried to keep moving, using the speed of their vehicles to redeploy from one patch of cover to another. All the theory about tungsten and velocity suddenly narrowed down to a few moments in which gunners had to choose which shell to load, and commanders had to decide whether the target in their sights justified the expenditure of a precious round. Field reports later described how some of those engagements played out. In the confused fighting near Lunéville around 18 September, tank destroyer guns that had struggled from the front with ordinary shot now finally had a different option. When a panther presented its glassy or turret face at the wrong distance, a tungsten core round could turn the situation on its head. Hits that once would have gouged and bounced now sometimes punched through, sending jagged spall ripping inside. The effect was not magical. The round still had to be used within its effective envelope of range and angle, but for crews who had spent months treating the front of a panther as something close to invulnerable, the difference felt dramatic. Yet the numbers told a colder story. Even as tungsten shells scored their first successes in the field, the total supply remained painfully small. By the end of September, only a few thousand rounds of the new type had been delivered from factories out of all proportion to the size of the front and the number of guns that could have used them. Crews in some units had first-hand stories of what the tungsten cores could do. Others knew the new ammunition only through rumors, seeing it mentioned in reports or hearing about it secondhand from passing officers who had seen the clean holes punched through captured Panther armor. Higher headquarters paid close attention to these scattered field experiences. Officers like Lieutenant Colonel Wilson Hawkins, who observed armored operations and gathered data through late 1944 and into early 1945, received a growing stack of notes and evaluations. Many of them echoed the same themes. When used correctly, the high-velocity tungsten rounds gave the 76mm and 3-inch guns a sharply improved chance against heavy German tanks. When they were not available, units often had to rely on flanking maneuvers or close assaults with infantry and artillery support, which increased casualties and complicated operations. This contrast sharpened the sense of urgency but did nothing to ease the industrial reality. Tungsten supply still lagged behind need, and other parts of the war economy continued to argue for their own critical uses of the metal. Cutting tools for aircraft factories, precision gauges, and machine shop inserts all competed directly with the penetrator cores needed by armored units. Even as reports from the front highlighted the tactical value of the new ammunition, the overall allocation of tungsten could only be changed slowly and at a cost to other programs. So the battalions at the front lived between two truths. On the one hand, they now possessed a round that could, in the right circumstances, rob the Panther of its greatest strength. On the other, they knew that each tungsten shot fired was one they might never see replaced. The fighting around Lunéville proved that the new technology worked in earnest combat, but it also underlined how dependent that success was on careful rationing and good judgment under fire. As autumn deepened and the war ground toward the borders of Germany, the question of how many rounds would reach the line, and where they would be sent, loomed larger over every planning table and supply manifest. While the tank destroyers in Lorraine were feeling the first sharp usefulness of tungsten rounds, a very different struggle was unfolding thousands of miles away on factory floors and in planning offices. In the United States, the high-velocity armor-piercing project existed at the junction of physics, metallurgy, and hard arithmetic. Engineers could calculate penetration curves and impact angles with neat precision, but production officers had to calculate how many tools a single tungsten core would cost them, how many lathes would run slower, how many factories would see their cutting edges wear out a little sooner. Tungsten's value was rooted in its stubbornness. It stayed hard at temperatures that softened ordinary steel, so machine tools tipped with tungsten carbide could cut faster and more accurately, shaving down the steel that became aircraft parts, artillery pieces, ship fittings, and 1,000 other wartime components. Before anyone had thought of putting tungsten into a tank round, it was already the quiet backbone of fast industrial machining. That meant every request from ordnance for more cores had to be weighed against the overall output of the war economy. Inside meeting rooms, planners spread charts on long tables. One line showed projected needs for tungsten-tipped cutters and press tools. Another plotted the growing demand for armor-piercing projectiles with tungsten cores for 3-inch and 76mm guns. Somewhere between those lines was a compromise that would keep the aircraft factories humming, the shipyards on schedule, and still feed at least some of the precious metal into the new ammunition. No compromise could ever satisfy everyone. Aircraft production argued that a shortage of cutting tools would slow down fighter deliveries. Ordnance argued that a shortage of tungsten ammunition would slow down the armored advance in Europe. In the middle stood the metallurgists and process engineers who actually had to turn theory into objects. Making a tungsten carbide penetrator was not simply a matter of melting and casting. The material was pressed and sintered, a powdered metal shaped under great pressure and then bonded at high temperature. It demanded careful control of heat and time. Too little, and the core would be weak and brittle. Too much, and its structure could change in ways that ruined its performance. Each batch required specialized furnaces, skilled operators, and testing to be sure it met the exacting standards needed for a projectile that would slam into armor at enormous speed. Production lines adapted as best they could. Some machine shops that once specialized in tool inserts now split their output between cutting edges and penetrator cores. Inspectors walked past rows of workers, measuring, checking weight and dimension, rejecting any core that did not fall within a tight band of tolerances. Even small flaws could turn into catastrophic fractures when the rounds struck hardened armor. Wastage was inevitable, and every rejected core felt like an accusation. It represented tungsten that had been mined, shipped, refined, and then lost to a tiny imperfection. As months passed, output climbed from almost symbolic levels into figures that looked more reassuring on paper, but the gap between need and supply remained. Early shipments to Europe, numbering in the low thousands of rounds, represented the first trickle. By late 1944 and into early 1945, tens of thousands of tungsten cores had been shaped and cased, yet demand from field commands always ran ahead. Armored divisions on the Western Front routinely asked for more than they received. Each request was filtered through the lens of broader strategy. Units expected to face heavier German armor along certain axes received priority, while others had to make do with what was left. From the factory standpoint, there was a certain cold clarity to the numbers. A given quantity of tungsten could either support a particular tonnage of industrial tooling or a certain stockpile of ammunition. The final tally by the end of the war would show that around 78,000 rounds of tungsten core high-velocity ammunition were produced for the relevant guns, a substantial figure at first glance. Yet when divided across all the fronts, across the many battalions equipped with 3-inch and 76mm weapons, it meant that only a fraction of engagements could ever be fought using the new round. The engineers followed reports from the field with great interest. They saw the technical phrases describing clean perforations of Panther armor at specified ranges, the notes about partial penetrations, shattering hits, and the influence of striking angle. These details were not abstract to them. They fed directly back into design tweaks, changes to nose shape, minor adjustments in weight distribution, even modifications to the metallurgy of the core. Every improvement, however, had to be judged against its impact on production. A design that was ideal on the test range but slowed manufacturing too much might not help the war effort overall. Behind the numbers and diagrams lay a quieter human story. Plant workers knew that the strange dense pieces they handled were destined for gun barrels in Europe and the Pacific. Some had sons or brothers in armored units, and for them the work took on a private urgency. Yet even with extra shifts and overtime, they could not conjure tungsten out of thin air. Or shipments still had to cross oceans threatened by submarines, still had to be refined and transported across a continent. Every stage held the possibility of delay or disruption. In the European theater headquarters, logistics staff tried to make sense of the flow. Charts on office walls showed ammunition shipments by type and month. Long lines of figures tracked how many tungsten rounds had been authorized, how many had left the factories, how many had crossed the Atlantic, and how many finally reached depots within striking distance of the front. Somewhere along that chain, losses and miscounts accumulated. A crate damaged in transit, a batch held back for inspection, a delay at a port because a crane had failed, all contributed to the sense that the new ammunition was always arriving slightly behind the pace of events. What made the situation more striking was the contrast with other supplies. Crews were used to seeing mountains of gasoline drums, endless stacks of small arms ammunition, walls of standard shells. Against this backdrop, the special high-velocity tungsten rounds always appeared in modest clusters, carefully labeled, wrapped in layers of caution and instruction. Their rarity set them apart, turned them into something almost symbolic of the entire relationship between technology and industry in modern war. The knowledge to outmatch the Panther's armor now existed, solid and proven. The means to apply that knowledge on a large scale remained limited by the stubborn realities of geology, shipping, and factory capacity. As winter approached and the front crept toward the borders of Germany, that gap between possibility and practice hung over both the firing ranges back home and the muddy fields overseas. Tanks and tank destroyers that received their share of tungsten rounds carried with them a concentrated fragment of scientific and industrial effort, a tiny hard core formed by the intersection of physics equations and labor in hot, noisy workshops. Whether that effort would be enough, and whether it would reach the right units at the right time, was a question no one in those factories could answer. They could only keep the furnaces running and the inspection lines moving, sending each new batch of cores into a war whose demands always seemed to stay a step ahead. By late 1944, the war along the Western Front had shifted into a harsher rhythm. The easy optimism that had followed the breakout from Normandy had faded under long supply lines, stubborn German resistance, and the creeping onset of winter. Armor units that had once driven rapidly across open country now found themselves holding exposed positions, watching snow gather in the ruts of frozen roads. In this new phase, the role of tungsten core ammunition was no longer just a rumor among a few battalions. It had become a small but visible part of the arsenal, though still so limited that most crews treated each round as a rare privilege. The first winter snows brought with them a new German effort, a counteroffensive through the Ardennes that would later be remembered for its sudden violence and confusion. In that tangle of forested hills and narrow roads, American tankers and tank destroyer crews faced not only Panthers but also heavy machines like the Tiger and Jagdpanther. Every encounter drove home the same lesson. Conventional armor-piercing shells from 3-inch and 76mm guns could defeat these tanks from the side under good conditions, but frontal shots remained risky and often ineffective at typical combat ranges. Whenever tungsten rounds were available, they were set aside for exactly these moments when German armor appeared head-on and there was no time or room to maneuver. In after-action summaries written during and after the winter fighting, a consistent pattern emerged. Units that had managed to secure modest stocks of tungsten core ammunition reported a handful of crucial engagements where these rounds had tipped the balance. Gunners described how, at a few hundred yards, a tungsten shot that began as a tiny streak of metal leaving the muzzle ended as a neat hole in armor once thought nearly invulnerable. The reports did not describe miracles. Some hits still failed when the angle was wrong or the range too long. But the difference between having a realistic chance at a frontal kill and having almost none at all was enough to change how crews thought about their guns. Among the officers tasked with gathering and making sense of these experiences was Lieutenant Colonel Wilson Hawkins, whose work in early 1945 drew heavily on field visits, interviews, and combat records. His notes tracked the performance of American armor against German tanks across a broad stretch of operations. He recorded that tungsten core high-velocity ammunition significantly improved the ability of 3-inch and 76mm guns to defeat heavy enemy armor, especially when fired from defensive positions where crews could choose their range and angle. Yet he also emphasized how rarely units actually possessed enough rounds to rely on them as a standard solution. For most engagements, crews still depended on ordinary shells and maneuver to find weaker spots on enemy tanks. Throughout these months, small adjustments filtered down to the line. Training directives reminded gunners to save tungsten for the heaviest targets and to use it only when certain of a good shot. Commanders revised ammunition scales, specifying how many tungsten rounds a vehicle should carry when supplies allowed. In some units, the preferred practice was to keep just a couple of tungsten rounds within immediate reach, with a few more stored deeper in the racks as a reserve. Others, short on supply, treated any tungsten they received as theater-level property, to be issued only for particular missions where German heavy armor was expected. This careful rationing shaped the way tungsten ammunition appeared in the historical record. Instead of a flood, it showed up as a series of small, sharp moments. A platoon of tank destroyers holding a road junction in the snow. A Sherman with a 76mm gun covering the approach to a village. An ambush laid along a forest track where scouts had reported Panthers moving at dawn. In each case, the decision to load a tungsten core round carried weight, because replacing that shot might take weeks, if it happened at all. The men who made those decisions were often aware that they were drawing on a resource measured in thousands of rounds across an entire theater, rather than hundreds of thousands. At the same time, German crews were discovering that their once comfortable confidence in frontal protection could no longer be taken for granted. Intelligence reports gathered from captured soldiers and intercepted communications revealed that some Panther and Jagdpanther crews were warned about new American ammunition capable of threatening them even from the front at certain distances. This knowledge did not erase their advantages, but it complicated the simple belief that they could dominate every head-on engagement. A Panther that had to worry about specific ranges and angles was a more cautious machine, slower to press aggressively into kill zones where American gunners might be waiting with the right shell already chambered. As winter gradually loosened its grip and operations shifted toward the borders of Germany, the feedback loop between the front and higher command grew tighter. Technical officers reviewed Hawkins' reports alongside others from Corps and Army-level observers. They used these documents to refine estimates of how many tungsten rounds each unit should ideally receive and how those rounds should be allocated between tank battalions and tank destroyer units. The consensus that emerged was sober. Even if industrial output continued to rise, tungsten core ammunition would never be plentiful enough to arm every gun for every battle. It would remain a specialized tool, reserved for critical engagements and specific threats. Yet it was precisely as a specialized tool that tungsten made its mark. Every time a high-velocity tungsten round turned a menacing panther into a destroyed hulk instead of an unbroken roadblock, it helped translate the enormous effort of research, metallurgy, and production into real changes on the ground. The effect was measured not only in burned-out German tanks but in the routes that could now be taken, the attacks that could be launched with slightly greater confidence, and the defensive stands that could be held longer because crews believed their guns had at least some answer to the armor facing them. The winter battles did not change the overall scarcity of tungsten, nor did they erase the brutal nature of armored combat. Tanks still burned, crews were still lost, and many fights were decided by terrain, weather, and sheer chance. But in the detailed reports that flowed from front-line units to analysts like Hawkins, a subtle shift was visible. The Panther, once seen almost as an untouchable predator from the front, was slowly being recast as a formidable but not invincible opponent, one that could be beaten if the right ammunition reached the right guns at the right moment. That shift in perception, grounded in hard experience and carefully recorded results, set the stage for the final months of the campaign, when American armor and tungsten core rounds would follow the fighting into the German heartland itself. When the snow finally began to melt along the Western Front in early 1945, the armored war in Europe entered its last, hardest phase. The forests and frozen fields of the Ardennes gave way to sodden ground, rivers in flood, and the first defensive belts along the German border. For American crews, the rhythm of fighting had changed from wild counterattacks to a more grinding advance, town by town and ridge by ridge. Yet even in this late stage, the familiar worry about German heavy armor never quite disappeared. Panthers, Jagdpanthers, and other thick-skinned vehicles still appeared at key road junctions and on commanding ground, and every one of them could still turn an advance into a stalled, smoking line of wrecks if mishandled. By now, the story of tungsten core ammunition was no longer confined to a few battalions. Supplies, though still limited, had grown from the thin trickle of the previous summer into something closer to a steady stream. Depots in the European theater could finally count their stocks not in mere hundreds or a few thousand, but in tens of thousands of rounds spread across the entire front. The total number shipped from factories back home climbed month by month, pushing toward a figure that would eventually settle around 78,000 by the end of the war for the 3-inch and 76mm guns. It sounded impressive when written in reports. Spread over all the units that wanted it, it still meant each crew received only a carefully measured share. Armored divisions preparing to cross into Germany found tungsten rounds woven into their planning the way bridging equipment and fuel dumps had always been. Staff officers estimated where resistance would be heaviest, which sectors were likely to be held by Panthers and other heavy vehicles, and which tank or tank destroyer battalions would therefore receive priority. One unit might be told it would get several dozen tungsten rounds per company, to be issued out as commanders saw fit. Another might be informed that none could be spared for the coming operation and that it would have to rely on standard ammunition and maneuver. Inside the vehicles themselves, the habits formed in France and Belgium held firm. Gunners and commanders still reserved tungsten for the most dangerous targets. By now they had a sharper sense of what those targets looked like in practice. A hull with broad sloping armor and a long-barreled gun facing their direction was a candidate. A lighter tank, an assault gun built on a medium chassis, or a thin-skinned self-propelled gun was not. Crews had also absorbed the lessons from winter experience. Tungsten rounds were at their best when the shot could be taken within a certain envelope of range and angle. Too far, and even the hard core lost some of its edge. Too oblique, and the round could skid away or only partly burrow in. As American formations forced crossings over rivers like the Ruhr and moved toward the Rhine, the terrain changed again. Industrial towns, rail yards, and factory districts replaced the hedgerows and farm villages of Normandy. In these built-up areas, lines of sight could suddenly stretch down long straight streets or across open rail approaches. Panthers used those lines well, setting up behind rubble or low embankments, their hulls mostly hidden, their thick turrets and upper fronts aimed down avenues they knew the attackers had to use. Under those conditions, even the most skillful flanking maneuver could be difficult. A vehicle that tried to sneak around might find itself exposed in the open between rows of ruined buildings. In such settings, tungsten core rounds stopped being an abstract advantage and became a practical tool. Reports from early 1945 told of gun crews who held fire with ordinary shells, waiting for the one moment when a heavy German tank presented a clean frontal target within a known range. When that moment came, the command to load tungsten went out quietly inside the vehicle. A single shot might mean the difference between a stalled battalion and a breach in the defense. If the round performed as the tests and earlier battles suggested, the Panther that had seemed to own the street could be reduced to a burning obstacle instead of an unbroken wall. Yet even as these successes accumulated, they sat alongside many engagements where tungsten simply was not present. In some fights, vehicles never received their share of high-velocity ammunition before being committed to action. In others, supply units had been diverted, bridges had washed out, or depots had been moved in haste as the front shifted. The same scarcity that had shaped the story in France continued to shape it in Germany. Tungsten cores were still the result of long supply chains and careful industrial balancing, and no amount of tactical demand could change the physical limits of ore and furnace capacity. Officers compiling summaries in March 1945, including observers like Wilson Hawkins, now had a broader base of data than ever before. They could compare the performance of units that had fought against Panthers with and without tungsten ammunition, noting differences in claimed kills, lost vehicles, and preferred tactics. The patterns matched what earlier field reports had hinted at. When tungsten was available and used carefully, American 3-inch and 76mm guns could hold a more confident line against German heavy tanks, especially in defensive ambushes or prepared positions. When it was not, units leaned heavily on artillery, air support, and close coordination with infantry to crack strong points held by Panthers and similar vehicles. At the same time, the wider balance of power was shifting. By spring, American armored formations operated with abundant fuel, strong artillery backing, and growing dominance in the air. German formations, in contrast, struggled with shortages of everything from fuel to trained crews. Panthers that had once ranged forward aggressively now sometimes had to sit motionless for lack of gasoline, hidden as reserve fire points rather than used as mobile spearheads. In that environment, the tactical value of tungsten ammunition existed alongside many other factors that tilted the battlefield. Still, the men who rode in Shermans and tank destroyers did not experience the war as a set of broad trends. For them it stayed personal and immediate. A Panther waiting at the mouth of a German village did not feel weakened by fuel shortages or production graphs. It remained a dark shape behind rubble, its guns steady, its armor thick. In those moments, the availability of a few tungsten core rounds for the vehicles tasked with facing it mattered intensely. Every decision about when to load one, which target to reserve it for, and whether to hold it back in case an even more dangerous vehicle appeared later, took place under the pressure of incoming fire and the need to keep the advance moving. As American forces crossed the Rhine and spread into the German interior, the same pattern repeated in new settings. Urban fighting in industrial cities, pushes through rolling country, clashes in forests that had not yet seen war, all brought fresh opportunities and risks. Tungsten ammunition rode forward in the ammunition bins of vehicles that had survived earlier campaigns, its presence the end result of decisions made in distant offices and factories months before. The crews who chambered those rounds often knew only the simple truth that these particular shells might give them one more option when they finally met a Panther face to face. By the time spring deepened and the armored spearheads were approaching the last defensive lines, field reports and production totals were starting to converge. The factories had pushed out most of what they could, the depots had distributed what they had, and the battalions had fired enough tungsten rounds in anger to form a clear picture of what they could and could not do. Locked inside those numbers was a story that ran from laboratory experiments and firing trials in Normandy through desperate winter battles, to these final advances on German soil. The answer to whether that story would fully play out before the fighting stopped lay ahead, in the last weeks of combat, when the remaining Panthers and their opponents would meet under the changing light of a war that was clearly nearing its end but had not yet released its grip.